Okay, welcome back to Mr. Hassan's Maths channel. In this video, I'm going to be going through the June 2019 Core Mathematics C34 International A-Level Edexcel June 2019 paper. Now this C34 papers are now they've become P3 and P4 separate papers. This is the old specification, and this particular question is question number 9 here, which is to do with trig identities, and this is something which would probably appear in the P3 exam, although you would need to know this for many of the questions in P4 as well. Possible that it could come in P4. Some manipulation of these trig identities is needed in P4 as well, but this is mainly a P3 topic. So it says, using the formula for sine A plus B and the relevant double angle formulae, find an identity for sine of 3x, giving your answer in the form sine of 3x equals P sine x plus Q sine cubed x, where P and Q are constants to be determined. So now we have to use the formula for sine A plus B. Now, if you don't know the formula for sine A plus B, it is in the formula sheet. Okay, so in the formula sheet, if you look at the formula sheet, you'll see something like this. Under trig identities, you'll see something that says sine A plus minus B equals sine A cosine B, and so on. So the one that we're looking for is this very first one. We're looking for the one that says sine of the angle A plus B is equal to the sine of A times the cosine of B plus the cosine of A times the sine of B. Okay, after a little practice you would know these formulae, but this is in case you don't know what the formula is. It's in the formula book. Alright, so how do we relate this to sine of 3x? Well, what I can do with sine of 3x is I can say let's split up sine of 3x into the sine of 2x plus x. We can say that the sine of 3x is the same thing as the sine of 2x plus x, or x plus 2x, doesn't matter which way you put it around. So in this case here, the a would refer to the 2x and the b would be like the x. So if we just rewrite this, instead of a I'll put sine of 2x, and instead of b I'll put x. So sine of 2x times the cosine of x plus the cosine of 2x times the sine of x. Okay, so now I have this written out in this form. Now what I have to do is use what I call the double angle formulae to try to reduce this, because as you can see, what we have to make it become is something with just sines in it. There's no cosines, and also we have to have single angles, so sine x, and that's sine cubed x, which is like sine x all cubed. So we don't have any of these two x's, only x's, sine x's. So what I'm going to do is I'm going to try to change the sine 2x into something which has just single angle. So from double angle to single angle. That's why it says use the relevant double angle formulae. Now that's not given to us in the formula book, but if you forget them, it's very easy to rewrite them using this particular formula here. Okay, so for example, for sine 2x, we can think of sine 2x as sine x plus x. That's sine of 2x. And if you just make a into x and b also into x, you're going to have sine x times cosine x plus cosine x times sine x. Well, they're both the same thing. So you have sine x times cosine x times another sine x times another sine x times cosine x, which is 2 sine x cosine x. So that's the double angle formula involving the sine of 2x. Alright, so I can replace this here, this sine of 2x, with 2 sine x cosine x. Alright, so that's one thing I can do. So what I'm going to do now is I'm going to just carry on down here. I'll say this is equal to, and I'll write this as 2 sine x cosine x. Okay, and that's multiplied by the cosine x over here. Plus, now cosine 2x. Let's look at cosine 2x. Now the cosine of 2x, if I use the double angle formula here, I can use, this is the same as cosine of x plus x, which means you can write the cosine of x plus x as, now if you look at it, cosine of a plus b is cosine a cosine b minus sine a sine b. So this will be cosine x times cosine x, which is cosine squared x, minus sine x times sine x, which is sine squared x. Okay, so that's using the double angle formula for cosine x plus x. And we want to have everything in terms of sines. There's no cosines in here. So what I can do here is use the very well-known identity that the cosine squared of x is the same as 1 minus 2 sine squared x. And I've got another, take away another sine squared x. So I'm left with, sorry, I'm jumping the gun there. I'm giving you the answer. Cosine squared x is the same as 1 minus sine squared x. And then I've got to take away another sine squared x, which is already here. This is 1 minus sine squared x. So I'm left with 1 minus 2 sine squared x. That's what cosine 2x. So I can write this as 1 minus 2 sine squared x. And that's multiplied by sine x. I'm just going to put a little line here to separate this working from that, so that it doesn't get mixed up. So that's like the steps that I'm showing. That's like the working I'm doing to derive these identities. So these identities, you should really know them. By the time you get to the exam, you should really know them like the back of your hand. You should know sine 2x is 2 sine x cosine x, and cosine 2x can be 1 minus 2 sine squared x. It could also be 2 cosine squared x minus 1, because if I change this into cosine 1 minus cosine squared x, I'll have cosine squared x minus cosine squared x, which is 2 cosine squared x minus 1. So that can also be written, if you need it, as 2 cosine squared x minus 1. But this is the one that we need because we want to have everything in terms of just sines. So now let me just continue with this. This gives me 2 sine x, and this will be times cosine squared x, and this will be plus, and if I expand this bracket, I'll have sine x minus 2 sine cubed x. Now I can do something with the cosine squared x, because I know cosine squared x is 1 minus sine squared x. I need to get rid of that, so I can write this as 1 minus cosine squared x plus sine x minus 2 sine cubed x. Now this I can expand. I'll do it down here so I've got more space. There will be 2 sine, sorry, what am I doing? This should be 1 minus sine squared x, of course. Cosine squared x is 1 minus sine squared x. Okay, so this will be 2 sine x, and 2 sine x times minus sine squared x is minus 2 sine cubed x. Then I've got plus a sine x here and minus 2 sine cubed x. So now we will end up with our answer, which is 2 sine x plus sine x, which is 3 sine x, and minus 4 sine cubed x. And hopefully that's the form that we need. Yeah, p sine x plus q sine cubed x. So the form they gave us was p sine x minus q, or plus q sine cubed x. Q sine cubed x. Okay, so that gives us p is equal to 3 and q is equal to negative 4. Okay, so there's the answer. This is actually how you need to express your answer, but you can go further and write that down. Okay, so that's what basically sine of 3x gives us. It gives us 3 sine x minus 4 sine cubed x. And I'm pretty sure we need this result in part B of this question. Pretty sure we'll need it, part B. So let's have a look at that now. And now for part B, we're told here, hence it says showing each step of your working, evaluate the integral of sine of 3x times cosine of x with respect to x between pi over 2 and pi over 6. So of course it seems we're going to have to use, as it says, hence, meaning using what we've just found. Okay, we're going to have to use this result that we found earlier. Okay, so what we're going to do here, we're going to replace the sine of 3x, pi over 2 and pi over 6. So sine of 3x is going to be replaced with 3 sine x minus 4 sine cubed of x times cosine x with respect to x. Now what I can do here is I can expand this bracket, and that will give me something which hopefully we can recognize how to integrate. So I have 3 times sine x times cosine x minus 4 times sine cubed x times cosine x, and that has to be integrated with respect to x. Now both of these I can spot that we are able to integrate these using the reverse of the chain rule, because I see something like a function multiplied by its differential. So the differential of sine x is cosine x. So the main function, I would say here, I'll just rewrite this as 3 times sine x to the power of 1. That's the main function, is something to the power of 1, and outside the function is the differential of what's inside the function. And here you have the main function is sine x all cubed. You can think of it like this, sine cubed x. So the main function is something cubed, and inside the function is sine x, and outside the function is the differential of what's inside the function. So this is a result of the chain rule. So this is to integrate this, we're going to get or use the reverse of the chain rule. All of this integrate with respect to x. So pi over 6 to pi over 2. So I've just rewritten it slightly so that I can recognize how we can work this. I'm also thinking there also would be a way of rewriting this using the double angle formula to give you something which can be integrated also. So I'll look at that later on in the end of the lesson, or the end of this video. I'll show you an alternative way of integrating this part, because I can think you can use the double angle formula to form it into one ratio which can integrate. But anyway, this one here, I know that this is the main function is something to the power of 1. So if I want to integrate that, I'm going to have to raise it to another power, to increase the power by 1. So I have sine x all to the power of 2 times cosine x. Then I divide by the new power and also by the differential of what's inside the function. So I write this as it is, except the main function, I'm going to increase its power by 1, divide by the new power, and also the differential of what's inside the function. Now the differential of sine x is cosine x. So I'm going to divide by 2 cosine x. And you can see here, the cosine x cancels out. All right, and that will give us our answer. Okay, and you'll see that if you differentiate this, we'll get exactly what we have here. All right, if you differentiate this, you get exactly what we have here. But let's see now. Then that's going to give us this one again, similar kind of thing. We're going to take this and we're going to increase its power by 1, leave everything else as it is, then divide everything by the new power and the differential of what's inside the function. And again, the differential of sine x is cosine x, and here the cosine x will cancel out, so will the 4's. And I'm going to have to put in from pi over 6 to pi over 2, not 3. Pi over 2. Okay, I wrote 3 there for some reason. Pi over 2. Okay, so now I have to put these values in. Let me just simplify this a little bit. All right, so this is going to give me, this is 3 over 2 sine, I'll leave it like this because it's easier for me to substitute the values in. Sine x all squared, and this is sine x to the power of 4, and I've got to put pi over 2 and pi over 6 in there, and hopefully that will give me my answer. Let's have a look. So we're going to have 3 over 2 times the sine of pi over 2, that part is squared, minus the sine of pi over 2 raised to the power of 4. That's that part. Then I've got to take away from that. I'll put a bracket here to keep it separate. That will be 3 over 2 times the sine of pi over 6, that's squared, minus the sine of pi over 6 raised to the power of 4. And we've got to be careful about the signs here. Now, sine of pi over 2 is the sine of 90, which is 1. So that's going to be 3 over 2 minus, and 1 to the power 4 is going to be 1 as well. So that's going to be 3 over 2 minus 1, which is a half, minus, let me keep the bracket here to save myself from getting something wrong. Now, the sine of pi over 6, which is the sine of 30 degrees, is a half. So 3 over 2 multiplied by a half squared, which is a quarter, minus, and this is the sine of pi over 6, again, this is the sine of 30, which is a half. A half to the power 4 is 1 over 16. It's going to be 1 over 16, right? Because the sine of pi over 6 is a half to the power 4 is 1 over 16. So now, let's just simplify this. That gives me 3 over 2 minus 1, which is 1 over 2. Okay, then I've got minus 3 over 8. Then I've got plus 1 over 16, because minus times minus is plus. So if I make these all over 16, it makes life easier. That's a plus there though, careful. That's going to be 8 over 16 minus 6 over 16 plus 1 over 16. And that will give us the answer of, that's 8 minus 6, which is 2, plus 1, which is 3. That leaves us with 3 over 16 as the final answer for this question. So 3 over 16 is the value of that integral that we were told to find. So there's the answer to part B. Okay, now I mentioned that there is another method that can be used also to answer this question, and that method is just for this part here, I could use a double angle formulae to rewrite 3 sine x cosine x in a way that I can integrate it without using reverse of the chain rule. Although reverse of the chain rule I think is easier, but just for your information, I know that the sine of 2x is equal to 2 times the sine x times cosine x, as we discussed in the previous part of the question. Now, that means if I want to go from here to here, if I rearrange this a bit, if I divide both sides by 2, I've got a half sine 2x equals sine x times cosine x. So if I have the sine of an angle times the cosine of the same angle, and I want to express that as a double angle, I can take the coefficient, which is 1, and divide it by 2, so half the coefficient, and I can double the angle and write that as a half sine 2x. So 3 sine x cosine x can be written as 3 over 2 times sine of 2x, and that's something I am able to integrate. So if I rewrite this as 3 over 2 times the sine of 2x, I can actually integrate this, and as I did in the last question, I'll write this as 4 times sine x cubed times cosine x, recognizing that as something I can use the reverse of the chain rule for. So pi over 2 and pi over 6. Okay, so now I can integrate each of these. This one integrates now as, well, the sine of something. If you differentiate, you get the cosine of something. So if you integrate, you're going to get minus, because the differential of cosine x is the differential of cosine x is minus sine x, so therefore the integral of sine x is minus cosine x. So this is going to give you negative 3 over 2 times the sine of 2x. Then I have to divide by the differential of what's inside the function, which is 2. Sorry, times the cosine of 2x, not sine, times the cosine of 2x, divided by 2. Then I'm going to have minus, and I have here 4, and as I said before, I can raise the power by 1, and then divide by the new power and the differential of what's inside the function, which is the differential of sine x is cosine x, and this basically cancels with these, and that's my integral. And now I can find the value, and hopefully it will give me the same value that we got before. So this is like minus 3/4 times the cosine of, and that's going to be pi over 2 instead of x, that's going to be pi, minus, they're going to have sine of pi over 2, and this is to the power 4. Then I have pi over 6 into here, which is minus 3 over 4 times cosine of 2 times pi over 6 is pi over 3, minus, and then pi over 6 in here, so it's going to be the sine of pi over 6 and all of that raised to the power of 4. So now, what does that give us? That's minus 3/4 times cosine of pi is -1, cosine of 180, and sine pi over 2 is 1, so that's minus 1 to the power of 4, which is 1, minus, and I've got cosine of pi over 3. Now pi over 3 is 60 degrees. The cosine of 60 is a half, so it's minus 3/4 times a half. And I've got minus, and this is sine of pi over 6. Now sine of, as we said, the sine of pi over 6, the cosine of, that's the cosine of 60 degrees, that's 1, so that's a half, sorry. The sine of pi, that's a sine of 30 degrees. The sine of 30 degrees is also a half, that's a half to the power of 4. Yeah, so the cosine of pi over 3 is the cosine of 60, the cosine of 60 is a half, and the sine of pi over 3 is the sine of 30, which is also a half. So that's a half times minus 3/4, and that's minus a half to the power of 4. Okay, now hopefully this is going to give us the same answer, which was 3/16. Let's see what happens. This is 3/4 minus 1, and that's going to become plus, that's 3/8, minus and minus is plus, and you've got minus 1/4 to the power of, half to the power of 4, which is minus 1/16. The minus is outside the bracket, so it's not also raised to the power of 4. So 3/4 minus 1 is minus 1/4, plus 3/8 minus 1/16. Let's bring them under one denominator, which is 16. That's minus 4/16 plus, and that's over 16. That's going to be plus 6/16 minus 1/16. So you end up with minus 4 and minus 1, which is going to be a minus 5, and minus 5 plus 6, which is 1/16, which I think was exactly what we got, and we got 3/16. What have I done wrong? 3 minus 1, 6 minus 4 is 2. Aha! Minus and minus is plus. There should be a plus here, and a plus here, so that should be 6 minus 4, which is 2, plus 1, which is 3. Okay, I'm not going to edit that out. It's very important. It's very, very easy to make mistakes, you see. That minus and that minus. In fact, what I should have done at this stage, let's just go back. I shouldn't have jumped the gun there. That's always a source of mistakes when you take shortcuts. So what I'm going to just do here, so sometimes it's good to make mistakes on these videos so you can learn from my mistakes as well, so that we, so basically what I should have done really, just to make it clear, that would be 3/4 minus 1, and then before I actually expand, that's minus 3/8, and that's minus 1/16, and then that's 3/4 minus 1, which is minus 1/4. That's going to be plus 3/8 and plus 1/16. Minus and minus is plus, minus and minus is plus. So you're going to have now minus 4/16 plus 6/16 plus 1/16, which gives you 6 minus 4, which is 2, plus 1, which is 3. That's 3/16, which is the same answer as we got before. So we know that we're correct now. And yeah, so this is just alternative method of basically integrating this part here. That part I did the same way, and of course it gives us the same answer, and that's using the double angle formula for this. But I think the previous method was actually simpler, where we just did the same thing here. Sin x is the main function, just power to the 1, and cosine x is the differential what's inside the function, so we use the reverse of the chain rule as we did here. That I think is easier, but both ways are perfectly fine. So that's the end of this question, part B. All right, and this is an alternative method for part B. Other questions from this particular paper can be found in the playlist that should appear somewhere in this area over here. Other questions from the topic of integration and from trig identities. So let's say trig identities here, integration over there from P3, and you can subscribe to my channel on this link. Thank you for watching, and see you soon.